four planar forces of magnitude 52 newtons, 39 newtons, and p newton acting at a point in the directions shown in the diagram. The system is in equilibrium. Find the values of p and theta. So the key word in this question is the equilibrium. So equilibrium means that the forces acting upwards must be equal to the forces acting downwards, and the forces acting leftwards must be equal to the forces acting rightwards. So the 52 Newton force is acting upwards to the north, and the 39 Newton force is acting completely to the right. But the p Newton force needs to be resolved since it has two components. So let's in this direction. This means that it has a leftward component which must be equals to p cos theta and a downward component which is equals to p sin theta. So let's make the equations as per these two conditions. So for the first one, so the 52 Newton force must be equals to p sin theta, and the 39 Newton force must be equal to p cos theta. So we know that sin theta over cos theta is equals to tan theta. Now that would simplify these equations. So let's say I divide both of these sides by p cos theta. 52 over cos theta, p cos theta must be equals to tan theta, since these two p cancel out and sin theta over cos theta remains tan theta. Now if you look closely, we have the value of p cos theta. So we can insert that value over here in the denominator. That means 52 over 39 is equals to tan theta, making theta is equals to 2 over 39, making theta is equals to 53.13 degrees. And now we can use this theta and use this in any of these two formulas. So I'll use this one. So 39 must be equals to p cos 53.13. So that means p is equals to 39 divided by cos 53.13, and this gives us the value of 65. So p is equals to 65 newtons. So with that we have the value of p and we have the value of theta. So for part B, they're saying that a bus travels between two stops A and B. The bus starts from rest at A and accelerates at a constant rate of A meters per second until it reaches a speed of 16 meters per second. It then travels at this constant speed before decelerating at a constant rate of 0.75 A meters per second, coming to rest at B. The total time for the journey is 240 seconds. So for the first part A, we need to sketch a velocity time graph for the bus's journey from A to B. This is a 1-mark question, so that means you do not need to have a lot of working for it. There are 3 different accelerations mentioned in this question. The bus starts from rest at A and then it accelerates at a constant rate before it reaches a speed of 16. So that means the initial speed is 0 and the acceleration is given as A, so it is unknown, and the final velocity is 16. Now for the second part, they are saying that it travels for a constant speed, meaning the acceleration is 0. But still, it is still operating at a speed of 16, which means the final and initial velocity will remain the same, which is 16 as well. The time for both of these different parts is not given, but the total time is given. So now finally for the last part, they say that after operating for a constant speed, it starts decelerating, which is 0.75 A. That means the acceleration will be negative 0.75 A since it is decelerating. And the initial speed will be 16. Velocity will be 0 since it comes to rest. So the total time is 240 seconds. So we will write 240 on the x-axis. And the maximum speed that the bus has reached is 16. So we will write it like this, 16. So for the first part of the journey, we'll write the initial velocity and we'll mark it as 0, 0. And then at a random mark, we will mark it. Two dots together. It moves for a constant speed. Then it moves at a constant speed for a specific amount of time. So we will draw a line. And now, for the last part of the journey, there is negative acceleration. So that means the gradient of the line will be negative and it will be downward sloping. For the first part, they've given us that the acceleration is a. Slope of the third line segment is lower than the first. It will be more flatter than the first segment. I will join the line from 16 to the point 240 on the graph. Okay, so for part B, we have to find an expression in terms of A for the length of time that the bus is traveling with a constant speed. So the length of time that it was traveling for a constant speed is this. But we don't have the individual time segments at these points, 1, which has been called T2. So in order to find the time segment, what we can do is that we can subtract the total time, which is 240, with T1 and T2. And we can call the length of time the bus is traveling at a constant speed as x this time. And T1 is this part. So for T1, we can use this information that we've written down. So we can use the v is equals to u plus at formula. So the final velocity is 16 and the initial velocity is 0 times a, and we can call this t as T1. So if we write it in terms of the time, it means that T1 is equal to 16 divided by a. Now as for this line time segment, we can use the v is equals to u plus at formula again. So the final velocity is 0 since it comes to rest, and the initial speed was this, which is 16, is negative 0.75 t. So that means when we rearrange this becomes 16 is equals to 0.75 t, and this t will write as T2. So 16 divided by 0.75 is equals to T2, which is equal to 64 over 3a. Sorry, I missed an a over here. This will become 64 over 3a. So if we write this again, this means that x is equals to 240 minus 16 over a minus 64 over 3a. And this is the length of time that the bus is traveling at a constant speed. For part C, they said that given that the distance from A to B is 3000 meters, we need to find out the value of A. So this is the velocity time graph between part A, and we know that the distance under the graph is always distance. So that means that the area under the graph is equal to 3000. And the graph is in the shape of a trapezium, and when we incorporate the formula of area of a trapezium, that will be half times the height, which is in this case is 16, multiplied by this base, which is 240, plus this entire base, which we will write as x. I have used x because this is the same x we used in part B, which was the length of time that the bus was traveling at a constant speed, which was this line. So when we simplify this formula, this becomes x is equals to 135. We can substitute this in this formula. So 135 is equals to 240 minus 16 over a minus 64 over 3a. So when we solve this, we get a is equals to 16 over 45.